Look up at the night sky. For millennia, humanity has gazed at the stars, mapping the heavens and charting the familiar paths of the planets. We thought we knew our solar neighborhood. We thought we understood where it ended. For a long time, Pluto was considered the edge of the line, the final outpost before the great dark void of interstellar space. But the universe is vastly more complex and vastly more mysterious than our ancient ancestors could ever have imagined. Beyond the orbit of Neptune lies a realm of icy bodies known as the Kuiper Belt. And for a while, astronomers believed this was the true boundary of our solar system. That was until a discovery shattered everything we thought we knew about the outer reaches of our cosmic backyard. We found something out there in the dark. Something so distant, so strange, and so inexplicable that it forced us to rewrite the history of how our solar system formed. This is the story of Sedna, a frozen time capsule from the chaotic birth of the Sun. A solitary wanderer on an orbit so extreme, it defies logic. Sedna is a ghost at the edge of our planetary neighborhood. It is one of the most distant known objects in the solar system, and its very existence points to a massive, hidden secret lurking in the dark. Welcome to the mystery of Sedna. Our journey begins in the year 2003. At the Palomar Observatory in California, astronomers Mike Brown, Chad Trujillo, and David Rabinowitz were engaged in a systematic search of the outer solar system, using the Samuel Oschin telescope. They were hunting for distant, slow-moving objects. Most things in the sky move quickly if they are close, and slowly if they are far away. The team was looking for the slowest of the slow. On November 14, 2003, they spotted it. A tiny, faint point of light moving against the backdrop of distant stars. But this was no ordinary object. Even from its initial movement, the astronomers could tell it was incredibly far away. They had found the most distant object ever seen in the solar system at that time. They named it Sedna, after the Inuit goddess of the sea, who is said to live in the frigid depths of the Arctic Ocean. It was a fitting name for a world located in the coldest, most remote regions of our solar system. When the discovery of Sedna was announced, it made headlines around the world. Here was a world roughly 3/4 the size of Pluto, located at an unfathomable distance from the Sun. To understand just how far away Sedna is, we need to talk about astronomical units, or AU1. AU is the distance from the Earth to the Sun, about 93 million miles. Pluto is, on average, about 39 AU from the Sun. When Sedna was discovered, it was roughly 90 AU away, more than twice the distance to Pluto. But that was just the beginning of the mystery. As astronomers continued to observe Sedna and map its path through space, they realized its orbit was unlike anything they had ever seen. Sedna doesn't travel in a neat, nearly circular orbit like the major planets. Instead, it travels on an extremely elongated, highly elliptical path. At its closest approach to the Sun, a point known as perihelion, Sedna comes within about 76 astronomical units. But at its farthest point, its aphelion, Sedna swings out to a staggering distance of over 900 astronomical units. That is nearly 1,000 times further from the Sun than the Earth. At that distance, the Sun would look like nothing more than a bright star in a pitch-black sky. Because its orbit is so massive, Sedna takes an incredibly long time to complete a single trip around the Sun. 1 year on Sedna lasts approximately 11,400 Earth years. Think about that for a moment. The last time Sedna was this close to the Sun, the Earth was in the midst of the last ice age. Woolly mammoths roamed the plains, and human civilization as we know it did not exist. By the time Sedna returns to this point in its orbit, another 11 millennia will have passed. Sedna is a world of extremes. It is incredibly remote, and because of its distance from the Sun, it is unimaginably cold. The surface temperature on Sedna never rises above -240 degrees Celsius. That's -400 degrees Fahrenheit. At these temperatures, things we consider gases on Earth, like nitrogen and methane, freeze solid. In fact, observations of Sedna suggest that its surface is covered in a mixture of water, methane, and nitrogen ices. But it isn't a pristine white snowball. Sedna is one of the reddest objects in the entire solar system. Its color is nearly as red as Mars. This deep red coloration is thought to be caused by organic compounds known as thalins. Thalins are created when complex carbon-containing molecules, like methane, are bombarded by ultraviolet radiation from the sun and cosmic rays over billions of years. This radiation breaks the molecules apart and forces them to recombine into complex, reddish-brown organic polymers. The presence of these thalins on Sedna's surface tells us that this world has been sitting undisturbed in the deep freeze of space for a very, very long time. Despite its size, estimated to be somewhere between 1,000 and 1,700 kilometers in diameter, Sedna is officially considered a minor planet or a dwarf planet candidate. One of the reasons it is so difficult to pin down its exact size and mass is that, unlike Pluto, Sedna appears to have no moons. Moons are incredibly useful for astronomers. By observing how a moon orbits a planet, scientists can easily calculate the planet's mass and density. Without a moon, Sedna's exact physical properties remain slightly ambiguous. But the greatest mystery of Sedna isn't its color, its size, or its temperature. The true mystery lies in its orbit. As we mentioned earlier, Sedna's closest approach to the Sun is 76 astronomical units. This is a very significant number. Why? Because the outer edge of the Kuiper belt, the region of space influenced by the gravity of Neptune, ends at roughly 50 astronomical units. This means that even at its absolute closest point to the Sun, Sedna never comes anywhere near Neptune. And that is a huge problem for our understanding of orbital mechanics. You see, the solar system formed from a spinning disk of gas and dust. Everything that formed in that disk should be on a roughly circular orbit. For an object to have an elongated, elliptical orbit like Sedna's, something must have pulled or pushed it out of its original circular path. Usually, that something is the gravitational pull of a giant planet like Jupiter or Neptune. Comets that originate in the outer solar system are often flung into the inner solar system by the gravity of the giant planets. But Sedna never gets close enough to any of the known giant planets to have its orbit altered by them. It is completely disconnected from the rest of the solar system. As discoverer Mike Brown famously put it, Sedna shouldn't be there. There's no way to put Sedna where it is. It never comes close enough to be affected by the Sun, but it never goes far enough away from the Sun to be affected by other stars. It is stuck in a gravitational no-man's land. So, how did Sedna get there? How do you place a world the size of Texas into an orbit that is completely detached from the known planetary system? This question has puzzled astronomers for 2 decades, and it has led to some of the most exciting theories in modern astronomy. The first theory is that Sedna is the first observed member of the hypothesized inner Oort cloud. The Oort cloud is a theoretical shell of billions of icy bodies that surrounds the solar system at a distance of up to 100,000 astronomical units. It is believed to be the source of long-period comets. However, the Oort cloud was thought to be much further out. Sedna sits in a region previously thought to be completely empty. If Sedna is part of an inner Oort cloud, it means that this region of space is not empty at all. Instead, it could be teeming with thousands of icy worlds, quietly orbiting in the dark. In the years since Sedna's discovery, a handful of other objects with similar detached orbits have been found. These objects, known as sednoids, lend weight to the idea that Sedna is not a fluke, but the tip of a massive, unseen iceberg. But even if there is an inner Oort cloud, we still have to explain how these objects got there. One leading theory is that Sedna's orbit was perturbed by a passing star. According to this idea, our Sun was not born in isolation, but in a dense cluster of stars. In the early days of the solar system, before the stars drifted apart, another star may have passed close enough to our Sun to tug on the icy bodies in the outer solar system, pulling them into elongated orbits like Sedna's. This means that Sedna's orbit is a fossil record. It is a frozen snapshot of the environment in which our Sun was born over 4.5 billion years ago. By studying Sedna and the other sednoids, we might be able to piece together the history of our Sun's birth cluster and the chaotic dynamics of the early stellar neighborhood. There is, however, another even more tantalizing theory. What if the gravitational pull that shaped Sedna's orbit didn't come from a passing star? What if the culprit is still here, hiding in the dark? When astronomers look at the orbits of Sedna and the other known sednoids, they notice something peculiar. Their orbits are not randomly distributed. Instead, they all seem to point in roughly the same direction in space. In a standard model of the solar system, the gravitational influence of the known giant planets would cause these orbits to precess or wobble at different rates. Over billions of years, their orbits should be randomized. The fact that they are aligned suggests that something is holding them in place. That something could be the gravitational pull of a massive undiscovered planet lurking in the outer solar system. This hypothesized world, often referred to as Planet 9, is theorized to be a super-Earth, perhaps 5 to 10 times the mass of our own planet, orbiting far beyond Neptune. If Planet 9 exists, its immense gravity could shepherd the orbits of objects like Sedna, explaining their bizarre alignment and their extreme distance from the Sun. The search for Planet 9 is one of the most intense and exciting astronomical hunts of the 21st century. And it was all triggered by the discovery of a solitary, frozen world called Sedna. Whether Sedna was placed in its current orbit by a passing star in the Sun's birth cluster, or whether it is being herded by the gravity of an unseen Planet 9, its importance to science cannot be overstated. Sedna is a messenger from the deep past and the deep dark. It reminds us that our solar system is not just the Sun and the 8 major planets. It is a vast, complex, and dynamic system that extends far beyond our current understanding. The discovery of Sedna proved that our cosmic map was incomplete, and it opened the door to an entirely new region of space waiting to be explored. As our telescopes become more powerful, and our surveys of the night sky become more comprehensive, we will undoubtedly find more objects like Sedna. We may even find the elusive Planet 9. But Sedna will always hold a special place in astronomical history. It was the first of its kind. The first glimpse into the inner Oort Cloud. The first hint that something massive might be hiding in the dark. Sedna continues its slow, solitary journey around the Sun. For the next several thousand years, it will drift further and further away into the cold, dark depths of space, before eventually beginning its long fall back toward the inner solar system. It is a lonely world, an untouched time capsule preserving the secrets of our solar system's origins. And as we continue to study it from afar, Sedna challenges us to keep looking up, to keep asking questions, and to never assume we have found the edge of the known universe.
If you enjoy this content and want to see more, please consider subscribing. A quick tap on the like button also helps us learn what topics you like best. Thank you for watching this video, and see you in the next one.